Hello everyone and welcome back. In this new lesson we are going to start the implementation of our messages service. This is going to be the observable based service that we are going to be using to interact with our error messages component from multiple parts of our Angular application. Let's start by creating here a new messages service.ts file here in our messages directory. So this is going to contain our observable based service. Let's define here a new class. We're going to be calling it messages service, and let's, as usual, make this an Angular injectable. And just like the case of the loading indicator service, we are not going to be declaring this as a global singleton. There could be different messages services in our application, each one linked to a particular component. We're going to be having one messages service here linked to the application root component, but we are also going to have a second instance of the messages service here in our edit course dialog so that we can display errors directly here on the dialog. Let's now create a pair of instances of the messages service and of our messages component. We are going to switch back here to our application root component, and we're going to be adding the messages component right here below the material toolbar. So below this red bar that we see here on top, we're going to be adding here a new instance of the messages component. In order to be able to interact in a decoupled way with this instance of the messages component, we are going to need an instance of the messages service that is accessible at this point of the Angular component tree. So if we open here our application component file, we're going to be adding here, next to the loading service, a new instance of the messages service. We could even inject this instance of messages service here directly in the constructor if we wanted to. But more important than that, this instance of messages service that we are creating here is going to be accessible to the application component template and to all its child components, including the messages component that we have created here. For example, the home component that we see here and that is going to be placed here instead of the router outlet could potentially need to show an error message to the user. Let's say that, for example, something goes wrong here whenever we try to load the courses. In that case, we would like to display here an error message to the user. In order to do that, we can go ahead and inject here in our constructor an instance of the messages service. And using this shared service is how the home component can interact in a decoupled way with the messages panel. Actually, the home component does not know even with which messages panel it's interacting with. It has no way of knowing that the messages panel that is going to be displaying the error message sits here on the top root component of the application. All that this home component knows is that it received here a messages service on its constructor, and it's via this service that we can show somehow error messages to the user. Let's now define the public API of the messages service. So what a component like the home component would need in order to show messages to the user is a public method that we're going to be calling here show errors. This is going to receive as its only input parameter an errors array, which is going to be an array of strings. Whenever the home component, for example, needs to display to the user a list of errors or even a single error message, all we have to do is call this method and the messages service is going to take care of everything. Let's give you an example. Let's imagine that here something went wrong while loading all the courses from the backend. In that case, the first thing that we need to do is to somehow catch the error here in our observable chain. So for that, we're going to be using here the catch error RxJs operator. Here, as the input argument of catch error, we are going to be receiving the error that the application has thrown. And here, as the output of this function, we need to provide a new observable that is going to replace the failed observable. We also want to call the messages service and inform the user that something went wrong. Let's start by defining here the error message that we want to show. We're going to define here a new constant called message, and we're going to assign it the message could not load courses. Let's now, before anything else, use the messages service and show this message to the user. Using this show errors input argument, we can pass in one or more strings as input separated by commas. In our case, we are only passing one message. Now we also want to log to our browser console and place there some trace that something went wrong. So we are going to log both the error message, but we are also going to log the technical error that we have received here. Notice that we are not necessarily displaying this error to the user because it might not make sense to the user. Now here, as the output of this method, as we have mentioned before, we need to return here a new observable that is meant to replace the observable that has errored out. So this observable highlighted here. Now in our case, we don't really want to replace the source observable with a new observable. We want to instead terminate our observable chain. So for that, we are going to be returning here a new observable using the throw error factory method, and we're going to pass it the error that was received here on catch error. So throw error is going to create a new observable that immediately emits the error and it ends its life cycle. So effectively, we are terminating here our observable chain. Yes, we are replacing this observable with another observable, but that new observable is going to immediately error out with the same error. So it's not like load all courses was replaced with a new observable that continued to emit values over time. What we did here with throw error was to make sure that the observable chain is terminated. And with this we have added here some error handling to our home component. Now the question is, how will the messages service now make this list of errors available to the messages component? Let's learn on the next lesson how can we implement this functionality using a reactive approach. Hello everyone and welcome back. In this new lesson we are going to continue the implementation of our messages service. This is the shared service that allows components such as, for example, the home component in our application to show error messages to the user using the error messages panel in a decoupled way by calling the messages service show errors public method. When we call show errors, the messages service will know to which instance of the messages panel to deliver the messages. So let's talk about the public API of the messages service. The messages service is going to be injected not only in our home component or in any other component under the application root component tree that needs to show errors to the user, but the messages service will also be injected, of course, in our messages component. So our messages component is going to receive here in our constructor an instance of the messages service. Just like the case of the loading component, also the messages component might potentially have multiple instances in our application. So let's add here some logging in our constructor and let's write here the message created messages component. This will help us to better understand how this component is used by our application. Now let's talk about how will the messages component interact with the messages service. So as usual, our messages service is going to be providing here in its public API an observable, and this is going to be the errors observable. This is going to be an observable that emits as values string arrays. So our arrays are in this implementation lists of strings. Using this errors observable, the messages component is going to be able to access the messages and display them to the user. Now let's make this messages service public so that it's reachable here via the template, and here in our template we are going to subscribe to the errors observable. We are going to be subscribing to the errors observable using the Angular ngIf syntax, and because we are already using here ngIf, let's use here an ng container in order to apply another structural directive. Let's remember that we cannot have two instances of ng if applied to the same element, and also we don't want to put another div around the messages container if we don't have to. So we're going to be using here ng container, and we're going to be using the ng if Angular structural directive. We're going to be accessing here the messages service, which is wrongly named. Let me quickly fix that. It's the messages service. Let's then access it here from ng if. We are going to be accessing here the errors observable, and we're going to be subscribing to it using the Angular async pipe. We are going to be aliasing the values emitted by the errors observable. Let's name this the errors local template variable. So this is an array of errors that is going to be available here to be displayed to the template using the ng4 directive. Now all we have to do is to implement these errors observable in our messages service. Let's switch here to our messages service and see how we are going to create this observable. So this observable is supposed to emit a new value whenever we call here show errors. Just like before, we are going to be implementing this custom observable by using a private subject. Let's define it here. We're going to define here a member variable called subject. Again, we're going to be using the behavior subject, which has the added advantage of remembering the last value emitted by the subject and making it immediately available to new subscribers. Just like the errors observable, this behavior subject is going to be emitting string arrays, which are going to be our application error messages. The initial value that we're going to be emitting is going to be the empty array. Just like before, we're going to be using the subject in order to create our errors observable. So the subject has the ability of emitting new values, new lists of errors, but the errors observable, on the other hand, does not provide that same ability. So we cannot use the public errors observable in order to emit new errors. If we want to emit new errors, we need to call here the show errors API. Let's now define here the errors observable. We are going to derive this observable again from the subject. We're going to apply here as observable, and this is going to create a new observable that emits the same values as the subject, with the difference that with the errors observable, we cannot emit new values directly. We can only subscribe to them. Now all we have to do is to implement here the show errors method. We're going to be calling here our subject, and we're going to call next on it in order to emit a new value of the errors observable. Let's pass in here the value that we want to emit, which is this new list of errors that we have received here. And with this, we have finished the implementation of the messages service. Let's now finish the implementation of our messages component. As we have seen, we are using here the messages service, and we are subscribing to the errors observable in order to pass the errors to the template. But the error messages are only going to be shown if this flag is set to true. So before showing the messages to the user, let's now see how can we set this flag to true whenever a new value gets emitted by the errors observable. I think that instead of subscribing directly here to the errors observable and setting the flag to true whenever a new value gets emitted, what we can do alternatively is to create here a new errors observable at the level of our messages component. So this is also going to be an observable that emits string arrays as values, which are going to be our errors. Now what we're going to do is we are going to consume this errors observable, which we have not yet defined, in our template. We are going to consume it here instead of the errors observable that is coming directly from the messages service. Let's now see how we are going to implement this errors observable. We are going to be deriving this local errors observable from the messages service errors observable. And we're going to be applying here the pipe operator, and as a side effect of each value emitted by the messages service errors observable, we are going to be setting the show messages flag to true. Let's apply here the tap operator, and let's then set the flag to true. Now, one last but important detail, let's remember that this errors observable will initially emit the empty array. So we don't want that empty array value to trigger here the display of messages to the user. Let's then change here the implementation of our errors observable, and let's filter out this initial value, the empty array. We're going to be using here the observable pipe syntax, and we are going to pipe here the RxJs filter operator. Here we are going to take the messages and we're going to make sure that the messages array is not empty. Let's first confirm that the messages array exists, and if that is the case, we are going to then check the length of the messages array in order to make sure that it's larger than 0. And with this last functionality in place, we have now finished the implementation of our messages service. So let's go again through our solution. Whenever a call to our backend fails, such as for example here this call to load all courses, we are going to get here an error. Using the catch error RxJs operator, we can then catch the error and use the messages service show errors public method in order to display an error message to the user. The home component does not know how the message is going to be displayed to the user, it simply knows about the messages service. The messages service is then going to emit via the errors observable a new value informing any part of the Angular application that needs to be notified that an error occurred. In our case, the messages component is then going to get notified via the errors observable that a new set of error messages need to be displayed to the user. This component is going to then set the show messages flag to true. That is going to trigger here the display of a panel containing the error messages that we want to show to the user. The panel is closable here via the close icon. And with this, our messages functionality is ready to be tested, and all we need now is to trigger some sort of error in our application. Now our home component is calling here load all courses. Let's quickly modify our backend in order to force an error to occur when this API gets called. We're going to open here our server folder where our small REST API server is running, that is serving here the list of courses. Here under the get courses route, we have here a very simple express route handler that is sending back to the client this list of courses that we see here on the screen. Let's modify this implementation and have it throw an error. Let's comment out here the correct implementation and notice here that inside this comment we have an implementation that always throws an error. So we're going to see here on the console log of the server, not of the browser, that there was an error loading the courses, and we're going to send back the HTTP status code 500 internal server error back to the browser with a small JSON payload saying simply that an error occurred. Let's now run this new version of our backend. We're going to go to the terminal and we're going to stop our server by pressing Ctrl C. Let's now run our new server with this new version of get courses by running the command npm run server. Let's now make sure that we are running the Angular CLI in our second terminal using always the command npm start. And with this, we are now ready to try out our error handling functionality. I'm going to switch here to a larger window and I'm going to reload the application. So this is still an old version of the application because we had there a list of courses. As we can see, as the application started up, we got here an error back from our backend. We can see it also here in our network tab. It's the request to /API/courses that return here 500 internal server error with the payload error occurred. We can also see that our messages panel is working correctly here as expected. So the messages panel extends through the whole top section of our application and it can be closed as well. So if I click here on the close icon, the messages are going to be hidden as expected. And with this we can see that our messages component is working as expected. Let's now see how can we apply the same functionality to the edit course dialog. Hello everyone and welcome back. In this lesson, we're going to continue to add error handling capabilities to our application. In the last few lessons, we have added error handling here to our home component that we can see here on the screen via the catch error RxJs operator and the show errors method from our new messages service. Let's remember that, going back here to our application root component, that our instance of messages service is only available to the application root component and to all its child components, including the home component. This messages service instance that we see here declared on the provider's property of the application root component is visible, for example, to the messages component that we see here at the level of the application root component template. So it's this error messages panel that we have seen on previous lessons that allows us to display errors to the user from multiple child components of the application root component. Now we would like to do something different, which is to add error handling capabilities to the edit course dialog that we see here. So in the particular case of the edit course dialog, we don't want to necessarily use the same messages component that the home component was using. And there are several reasons for that. The first reason is that the edit course dialog is a component that exists in a completely different branch of the Angular component tree than the application root component. So for example, this instance here of the messages service is not visible at the level of the dialog. So if we would now try to inject the messages service here in our course dialog component, we would get an error saying that there is no provider for messages service. This is a very important point. The service declared here on the provider's property of the application root component will only be visible to the component and its child components, but not to the course dialog component, which exists in a completely separate branch of the component tree. So that's the first reason why we would like to use a different messages service here in our course dialog component. Now, even if the course dialog component and the application root component would be on the same component tree, we would still want to use here a new instance of messages service. And why is that? This is because in the particular case of a course dialog, we want to be able to display the errors to the user here directly on top of the dialog. So we would like the error messages to be displayed here inside the dialog itself and not outside the dialog on the application-wide messages panel that sits on the main screen just below this red bar that we see here on the background. The user would not be able to conveniently see the error messages if we would use the global error messages panel. So here in our course dialog component, the first thing that we're going to add is a new instance of our messages component. This is so that we can display an error message panel here inside the edit course dialog whenever, for example, an error happens on the backend whenever we try to save a new version of a course. So now we have here a different messages component. It's not the same instance of messages that we have here in our application root component. So there will be two instances of the messages component in our application. One at the level of the root component and another at the level of our course dialog. Now all we need is a way for our course dialog to be able to interact with its own messages panel. And just like we did before, we are going to be able to interact with the messages panel via a shared messages service instance. As we have mentioned before, we cannot inject here in our constructor the same instance that we have declared at the level of the application root component. So this attempt of injecting here the messages service would result in a dependency injection error. However, what we can do in a very similar way to what we did with the loading service is to declare here a new instance of the messages service, which is local to our course dialog component. So this new instance of messages service will only be visible to the course dialog component and its child components. This instance will also be visible to the messages panel that we have here inside our course dialog. So that's exactly what we need in order to interact with our messages panel from our course dialog. We can now use here the messages service and add error handling capabilities to our dialog. We are going to do so by using the RxJs pipe syntax here in our save course observable, and we're going to be using the RxJs catch error operator. The catch error operator is going to receive here the root cause of the error. So the first thing that we're going to do is to define a new error message that we want to display to the user. Let's simply write could not save course. Now we want to log this error message here to the console, but we also want to log the root technical cause of the error, which we have available here on the catch error operator. Now we are not going to be showing this error to the user because this is usually a technical error, such as for example a stack trace, and this would not make sense to the user. Instead, we are going to be showing only this user-friendly error message by calling our messages service instance. Let's remember this service instance is local here to our course dialog. It's not visible in other branches of the Angular application tree, and this service is what allows us to interact with our local error messages panel that we are going to be displaying here inside the dialog, as opposed to here at the level of the application main screen. Now, in order to complete the implementation here of catch error, we need to return an observable. This observable is meant to replace this observable here that has errored out. Now, in our case, we simply want to reflow our error up the RxJs chain. So we're going to be using here the throw error RxJs utility, and we're going to pass in here the same root cause of the error. So yes, we are replacing this observable here with another observable, but that new observable is going to immediately error out with the same error cause. This will effectively interrupt the operator chain, and this will allow us to display to the user a user-friendly error message. We are now almost ready to try things out, so what we're going to need is a way of having a failing save request here in our course dialog. Just like we did before, we are going to switch here to our server that we are running, that is a small express server, and we're going to look for the save course route. This is the express route that gets triggered whenever we click here on save. Let's have a look at it. So as you can see, it's a very simple implementation, and we even have here some code that we can uncomment that will allow us to easily fail a save course request. So let's temporarily uncomment this code so that we can simulate an error and see the error handling functionality in action. Now, if you remember, in order to trigger an error in the home component, we also modified here the get courses route in order to always throw an error. In order to be able to access the dialog, we need to fix this get all courses endpoint. Let's comment out this functionality here, which was forcing an error each time that we loaded here the courses on the main screen, and let's put back the correct working functionality again. With this in place, we are now going to restart our server. So we're going to head over here to the terminal, and we are going to hit Ctrl+C on the terminal window where we have our server running, and we are going to start the server again on localhost 9000. With this in place, we can now test out our new functionality. So I'm going to switch here to a larger window, and I'm going to reload the application just to confirm that the get courses endpoint has been fixed. So as we can see, no error was thrown. Now, if we click here on edit course and we try to do some modification here on the course data, and we click on save, notice what will happen here. Now we can see here an error messages panel here inside the courses dialog, displaying the message could not save course as expected. And with this, we have finished the implementation of our error handling functionality in our course dialog. Now, in the next section of the course, we are going to talk about state management for data, such as, for example, the courses data that we see here. Before starting the new section, let's leave our application in a functional state. So we are going to switch back here to our IDE, and we are going to open here our save course route in our server, and we are going to comment out here the functionality that was simulating a save course error. We are going to switch back here to the terminal, and we are going to stop our REST server, and we are going to now start it again using npm run server. This way we have again a fully functional backend, and with that we are going to be able to start adding state management to our application using observable data services. Hello everyone, and welcome back. In this new section of the course, we are going to start to add state management to our application. So far, our application has remained mostly stateless. So whenever we reload our application and we access here the home component, we're going to get back from our backend a list of courses by triggering here the load all courses request. Our home component is then going to make the data available to the home component template via these two observables that are then directly subscribed to in our template using the Angular async pipe. Notice that the data is retrieved from the backend via an HTTP request, and it's directly passed on to the template using the async pipe, and it's not kept anywhere else in our application. The template is then going to transform this data into HTML that we see here on the screen, and that's why we can visualize here the list of courses. If we trace the flow of the data through the application, we're going to see that the data came here from the backend via the Angular HTTP client, and we can also see that the courses service did not keep in memory any reference to the data. Also, the home component has passed on the data directly to the template using these two observables without keeping a reference to the data. So once the data gets transformed into HTML by our component template, we can no longer access that data. That data payload that we got from the server is going to be discarded, and it will no longer be present in memory in our client. All we have left is the HTML that was used in order to visualize the data. What are the main implications of this approach? Well, one of the main consequences is that whenever in our application we switch to another page, such as for example the About page, and we get back here to our main page, we're going to see via the presence of the loading indicator that the data was again loaded from our backend. To better understand what this means, let's switch back here to a larger window, and we're going to reload our application. Notice the presence of the loading indicator, and also here the courses backend pending request that we saw there. We have here the GET request that was executed in order to get the data from the backend. And now if we continue to keep an eye here on the network log, we're going to go to our About screen, and we're going to click here on the back button to go back to our home screen. And notice here we have a second HTTP GET request to /API/courses. So if we go back again to the About screen, back to the home screen, we have yet a third request. So in only a few seconds, we have fetched the exact same data from the backend each time. Now let's see what will happen if we try to edit a course. We are going to edit here the title of the course, and let's click save and keep an eye here on the network log. So first we have here our save request with a loading indicator, and now we have another GET request to the backend to fetch the new version of the data from the backend. We have here the new title displayed on the screen, but in order to be able to display the new title, we had to do another backend request and show again another loading indicator to the user. As we can see, this is the main consequence of adopting a stateless solution. It's very easy to maintain, to develop new features, to reason about, but whenever the data changes in our application, the only way that we have to update the view is to bring again the data from the server. And even if the data is not modified, if we navigate away from the screen that fetched the data that we want to display and we come back to that same screen, such as for example the home component, we are going to have to reload the data again. So if we now click here on about and go back here to the home component, we have yet another request to our backend. As we can see, one of the main consequences of not using any state management in our application is that we have a lot of network overhead. We have a lot of HTTP requests that often end up fetching the same data again and again. Also, with data modifications, we will have to contact the server, modify the data on the server, and fetch the new version of the data from the server again. So this means a lot of loading indicators shown to the user and a lot of network overhead to our application. Now, this might not be a problem at all for a wide range of applications. Stateless solutions such as this one might be perfectly adapted to a large number of applications, and we should only have state management in our application if we really need to. However, there are situations and particular use cases where, for example, the data that we are showing to the user does take some time to get from the backend. So the backend request might take, for example, 5-10 seconds. We would like to avoid having to show to the user constantly loading indicators for every single operation in our user interface. In order to give the user a better user experience with less network requests and less loading indicators, we are going to have to add some state management to our application. This means that we are going to have to take the state that we are bringing from the server, which in this case is the list of courses, and we're going to have to manage it in some way. We're going to have to store it in a place in our application where it will be easily reachable by the multiple components that need it, such as, for example, the home component. This statement management logic that we are about to add to our application is going to make the application a little bit more complex, but it will also have the added benefit of a better user experience. In the next few lessons of this section, we are going to learn some simple techniques to add state management to our application. Now, in the concrete case of the application that you maintain, you are going to have to decide on a case-by-case basis if it's worth it to add state management. My general recommendation is to try to keep your application stateless and only add state management if you really need to improve the user experience. If you have network requests that are very slow, that are really harming the user experience, if you are showing a lot of user indicators to the user, if there are long backend delays, then in those cases you can consider state management. Otherwise, having a completely stateless front-end solution also tends to work very well for a large number of use cases. And with these trade-offs in mind, let's now get started adding state management to our Angular application. Hello everyone and welcome back. In this new lesson, we're going to start to add state management to our sample Angular application using some of the same reactive techniques that we have presented earlier on in this course. The first screen to which we're going to be adding state management is going to be the home component. Now, the home component receives here as input a list of courses that comes here from this call to our courses service. As we have seen, the current version of the home component is completely stateless. We get the courses here from load all courses, which calls our backend using the Angular HTTP client. Then this data is passed on to the template using the async pipe, and the data is directly transformed into HTML by the home component template. This means that we lose all references to the data, so if we need the data again in our application, for example after a navigation away from the home component, we are going to be forced to call reload courses again and to fetch the data from the backend again. In order to avoid this, what we need to do is instead to keep a reference to the data that we got from the backend somewhere in our application. This way, whenever we need that data, we can obtain it from the client side in memory instead of having to call the server again. Now, where are we going to store the data? In this case, the list of courses. We are going to store it in a separate shared service. Now, that service is not going to be a stateless observable-based service like the courses service. So the courses service that we are using to fetch the data from the backend is essentially stateless, in the sense that we don't keep references here to the data that gets retrieved from the several methods that are exposed here in the courses service API. The data gets returned to the caller of the method, but the service itself does not keep the data that was retrieved from the backend in memory. In order to add state management to our application, we are going to be needing a different type of service. This new type of service, instead of being stateless, is going to be stateful. This means that the service is going to keep some state in memory, such as, for example, a list of courses. In order to make it clear for anyone maintaining the application that this type of service is a stateful service, we are going to be calling this type of services a store. So we are going to be creating here a new file that we are going to call courses.store.ts. Let's now define the skeleton and parts of the public API of this new service. Let's create here a new class that we're going to be calling courses store. We are going to be annotating this with the Angular injectable decorator, and in the particular case of this courses store, we want to make it a global application singleton so that any part of the application can access the courses data. In this case, there is no good reason for different parts of the application to have their own separate copy of the data. The data should be the same for the whole application. So that's why we are going to be making this a global service by specifying here the provided in property, and we're going to set it to root, meaning that we will have only one instance of courses store for the whole application. Let's now start defining the public API of this service. So just like the case of other services that we have built in our Angular application, we are going to be using here a reactive API, meaning that observables are part of the public API of this service. The most important part of this API is going to be a new courses $observable that we are going to be defining here as an observable of course array. So this is going to be a publicly available observable that any part of the application is going to be able to subscribe to in order to obtain the latest version of the courses list. Now, the multiple parts of the application that subscribe to this observable are not going to be aware where and when the data is coming from. They don't know if the data comes from the backend or from an in-memory variable. They just know that whenever this observable emits a new value, that value is going to contain the latest version of our courses list. Besides the courses observable, the public API of the courses store will also contain other methods that will allow us to modify the course data. Besides data modification operations, the courses store might also expose functionality that allows us to more easily consume the data that is stored in memory. We can imagine, for example, here a new method called filter by category that would allow us to easily get back only the beginner or advanced courses, for example. This filter by category method would receive here as input parameter a course category, which would be a string, and the output of this method is going to be an observable of course array. Now let's see how would we implement this method. We are going to be returning here a new observable that is going to be derived from the courses observable. Let's use then the RxJs pipe syntax, and we are going to apply here the map function in order to transform a general list of courses into a list of courses with a particular category. So here we are going to be receiving the full list of courses. Let's then apply the array filter method, and let's write here our filter function. The filter function is going to take a course and it's going to return true if the course category matches the input category of our filter by category method. Let's add here some extra formatting so that we can see what is going on. So here we have the filtered list of courses. Let's also sort this by sequential number. So I'm going to apply here the sort function and I'm going to pass it the compare function sort courses by sequence number. With this, the output of filter by category is going to be a list of courses that belong to only a given course category. Before continuing the implementation of the courses store, let's see already how this filter by category method is going to be used. We are going to take the courses store and we're going to go ahead and we're going to inject it here in our home component where we want to display a list of courses. Let's create here a new member variable. We're going to call it courses store and we're going to have it injected here in our constructor. This means that our home component will no longer have a fully stateless implementation. Instead of fetching the data using the courses service, now our new version of the home component will get all its data from the store instead. This means that we will no longer be creating here our courses observable, and it also means that we will not be needing here our loading indicator or error handling capabilities here at the level of the home component. All of this is going to be handled by our store. We can go ahead then and remove here the messages service and the loading service from our constructor. Now let's see how will the beginner courses observable be defined then. We are going to be defining this by calling here the courses store and we're going to be calling the filter by category method and we're going to ask for the category beginner. In a very similar way, we are going to be doing the same for the advanced courses observable. We are going to call filter by category and we're going to specify the category advanced. As we can see, moving all the logic for loading the data from the backend and calculating the error handling and managing the loading indicator to the courses store has greatly simplified the implementation of our home component. All that the home component is aware is that there is a store somewhere in our application with a public observable, the courses observable, that is going to give us back the data when it's available. The courses store does not know if the data comes from the backend or from an in-memory cache that is transparent for the home component. This is going to give us a lot of flexibility in how we are going to implement the courses store. Let's then continue the initial implementation of our store and see it already in action in our next lesson. Hello everyone and welcome back. In this new lesson we are going to continue the implementation of our courses store. So our goal is to add some state management features to our Angular application. We want to be able to load the courses and keep the list of courses in memory for whenever we need it, without having to fetch it back from the backend multiple times as we navigate through our application. We also want to make the list of courses available via a courses observable that we have defined here. As we have learned in the previous lessons, while we were building our messages service and our loading service, the best way to define a custom observable in Angular is to use a private behavior subject. So we are going to be using the same technique here. Let's make this a new behavior subject. And let's pass in here the parametric type that identifies the values emitted by this subject, which are going to be course arrays. We are going to be passing here as the initial value emitted by this subject the empty array. This subject is then going to be used to create our courses observable. We are going to derive here from the subject using the asObservable method a new observable that emits the same values as the subject, but the consumers of the service will not have access to the subject because it's private. This means that the consumers of the service will be able to subscribe and receive new values of our courses list without having the ability of emitting new values themselves. So the ability of emitting new values for our courses observable is encapsulated and kept private inside our courses store. The first thing that our courses store will need to do is to load the courses from the backend and emit them via the courses observable. So for that, we are going to be injecting directly here the Angular HTTP client. We will also be needing other things to implement our courses store. We will need the ability of showing a loading indicator to the user. So let's go ahead and inject here the loading service. And we will also need the ability of showing errors to the user. So let's go ahead and inject here also the messages service. In our constructor, whenever the store gets initialized for the first time, we are going to be calling here a new method that we are going to be calling load all courses. Let's go ahead and implement this method that we want to keep private to our courses store. So this method will not be accessible to anywhere else in our application, meaning that the courses are only going to be loaded from the backend once at application startup time. In order to fetch the courses from our backend, we're going to be using here the Angular HTTP service, and we're going to do an HTTP GET call. We're going to be hitting the endpoint /API/courses. Let's define here the expected return type, so we would expect to receive from the backend a list of courses. The actual response from the backend is going to include an object containing a payload property, which will then provides us with a list of courses. So let's go ahead and using the RxJs pipe syntax, let's apply here the map operator, and let's take the HTTP response and let's extract from it the response payload. If something goes wrong whenever we are doing a call to our backend, we also want to add here some error handling. So let's go ahead and apply here the RxJs catch error operator. And here we are going to be adding the same error handling functionality that we have explained in detail before. I'm going to paste in here the implementation and let's review it together. So we are going to be defining a new error message, could not load courses. We are going to show it to the user using the messages service. We are also going to log the error message to the console together with the original technical error that the user might not be able to understand. So that's why we are not going to be showing it on the error messages panel. We are only going to be showing the user-friendly could not load courses. We are also returning here via throw error an observable that is going to error out the observable chain with the same error cause. Let's now assign this observable to a new variable that we're going to be calling load courses. We are now going to be adding some loading indicator capabilities to this observable. Let's call here the loading service and let's call show loader until completed, and let's pass it the load courses observable. We are going to get back here a new observable with loading indicator capabilities. So the loading indicator is going to be shown whenever we subscribe to the output observable, and the loading indicator is going to be hidden when the observable finishes its life cycle. Now, if we don't subscribe to this observable, nothing will happen. So let's go ahead and subscribe here to the output observable. So now we are retrieving the courses from the backend, but we are not yet saving them somewhere in memory. Now, in order to do that, we are going to be using the subject. So what we want to do is whenever we get the data from the backend, we want to call subject.next and emit that data to any part of the application that might be interested in receiving it, such as, for example, our home component. So we are going to be doing that as a side effect of our observable chain here after catch error. So if no error occurred, then we are going to be receiving here at this point of the observable chain our list of courses. Let's go ahead and call our subject. We're going to call next on it, and we're going to have it emit this new list of courses that we received from the backend. Like we have seen before, this is going to be done only at service construction time, so this will happen only once during the application lifecycle. This method is private, so it cannot be called elsewhere in the application multiple times. We are now at this point in the course almost ready to try out our first state management solution. However, if we would try to load our application as it is, we would see an error in the console. Switching here to a larger window where the application has already been started, we can see that this has crashed, and we have here the error no provider for loading service. So let's try to understand what is going on here and let's fix this issue. Going back here to our application, what is happening is that this courses store service, which is a global singleton, needs instances of the loading service and of the messages service in order to be able to work. Now, the only instances that we have on our application defined for these two services are the ones available, for example, at the level of our application root component. So if we open here our application root component, we are going to see that we have here one instance of each of these services. Now, the problem is that these services, because they were defined here at the level of the application root component, are only visible to the application root component and other child components. They are not visible to global singletons such as the courses store service. So how can we fix this? Instead of defining these services here at the level of the application root component, we are going to open here our application root module and we are going to define two instances of these services here in the providers property of the application root module. So we are going to be defining here the loading service and we are also going to be defining here the messages service. And if we now try this out, our application is going to work as expected. Let's wait here for the reload. Let's keep an eye here for the loading indicator. So here it is, and the courses have been loaded via our courses store. So now, if we navigate here to the About page and we go back to the Home component, we are going to see that immediately we are going to be displaying on the screen the list of courses. We didn't see here any loading indicator. I'm going to do this again. We are now on the About page. Let's go back to the main page, and as we can see, no loading indicator was activated because the data was fetched directly from our courses store instead of having to trigger a new backend call to get the same data again from our backend. If we now try to edit the course using the edit course dialog, let's say that, for example, we are going to change here the value of the title. If we now click on save, we're going to see here the loading indicator to save the data in our backend. And we are back here to the home component. But notice that because our course dialog is not yet using state management, the new value of the title has not been reflected in our user interface. So we have here a data inconsistency that would cause some confusion to the user. We can see the new data by refreshing here our application. The data has been now fetched again back from the backend. So in the next few lessons, we are going to learn how to add state management also for data modification operations. At this point in the course, it's important to understand, going back here to our application code, that there are still two instances of loading service and two instances of messages service in our application. For example, taking the loading service, we have here one instance at the level of the root of our application that is also visible at the level of our application root component. So this instance here defined in our application module is going to be available here to the messages and loading component of the application root component. But besides this, we also have separate instances of loading service and messages service that are local to the dialog. And with this, we have the initial version of our courses store up and running. As we can see, this technique using behavior subject is very flexible. It's a very simple way of adding lightweight state management to your application without introducing a lot of code and other third-party libraries. Let's now finish the implementation of our state management solution for our courses list. We are going to next talk about data modification operations. Hello everyone and welcome back. In this new lesson, we are going to show how can we adapt our courses store in order to allow also data modification operations. So far our store is loading the courses data from our server at startup time via the load all courses private method. What we want to do now is to expose in the public API of our store a new method called SaveCourse that is going to allow us to modify the data of a particular course. Here is how this is going to work. We are going to do the data modification in an optimistic way, meaning that we are going to modify the data of the course directly in memory, and we are going to emit the new value of the data via the course's observable immediately. So we are not going to wait until the data gets saved on the backend before notifying the rest of the application. This is going to give us a very responsive user interface where any data modification operation gets immediately reflected in the user interface without the need to show a loading indicator to the user. Our store is then going to save the data in the background without interrupting the user experience. Let's then learn in detail how can we add optimistic data modification capabilities to a behavior subject store. The first thing that we're going to do is to adapt the public API of the courses store. So we have here a method called filter by category in order for consuming data from the store, and we also have here as part of the public API the courses observable in case that we want to subscribe to the complete list of courses. We are now going to be adding here a new method that we're going to be calling SaveCourse. Now let's see what parameters will this method take. So the first parameter that we're going to receive here is going to be the course ID, which is a string. This is the unique identifier of the course that we want to modify. The second argument that we're going to receive is going to be the changes that we want to perform to a given course object. So this is going to be of type partial course. So this type partial simply means that the object that we are passing here, changes, is not an object that follows all the rules defined in the course interface. So all of these are declared as mandatory properties. Instead, the partial course will be able to allow us to define a type safe object that, for example, contains only the description and the long description, which would be the two fields that we would like to modify in a given save operation. So now that we have defined the public API of our SaveCourse method, let's see how we're going to consume this new SaveCourse operation. So the modification of courses happens here in our Edit Course dialog that we can open by clicking here on the Edit button. This dialog here is implemented via the Course dialog component. So here is where we are going to be needing our store instead of the courses service. Let's then go ahead and inject here in our constructor the courses store. We will no longer be needing here the courses service, and we will no longer need here the loading service. Let's remember that if we would need a loading indicator, we would use it at the level of the store service and not of the course dialog component. We are still going to be needing here the messages service in case that we want to display an error message to the user locally here at the level of the course dialog component. Let's remember that the error messages that are generated here are going to be displayed here on top of the dialog. Let's now see how can we use the courses store in order to modify our data. So here on the save method that gets called whenever we click here on the save button, we're going to be calling the courses store instead of the stateless courses service. As we can see, the save course method of the courses service had a very similar API to our courses store save course method. We are still passing here an identifier of the course that we have available here at the level of our dialog, and we are also passing here an object containing the partial changes that we want to perform to a given course object. So we have forgotten to define here the return type of the SaveCourse method, which is implicitly currently void because we are not returning any value here. Let's make this instead an observable of any. So we are still returning an observable to the caller of this method that is going to successfully complete when the SaveCourse operation is successfully performed in our backend, but this observable that we are returning here can also error out in case that our save operation fails in our backend. So this way we are going to be able to provide some local feedback at the level of the component that has called the data modification operation and handle errors locally if necessary. Notice that unlike our previous implementation, we will no longer show a loading indicator to the user while the save operation is ongoing. Our save is going to be optimistic and done completely on the background without blocking the user interface and degrading the user experience. So let's go ahead and remove here our use of our loading service. So as you can see, just like the case of the home component, using our store to do all the state management for the courses entity has also simplified the implementation of our course dialog component. Notice that unlike before, we are no longer using here the save course observable, and more specifically, we are not subscribing to it. So let's remember to subscribe to this observable, otherwise, as usual, nothing will happen. After triggering our optimistic save operation by calling subscribe, we are now going to close our dialog. Let's use here the dialog reference, let's call close, and let's pass in here some value in order to distinguish the case when the save was successful from the case where we simply closed the dialog without doing any modification operations via the close button. Now we are doing here some local error handling, but because we are closing the dialog immediately while the save is still ongoing on the background, this error handling logic that would use here our local messages service would not be of any use because we are trying to display here an error message on top of the dialog, which has meanwhile been closed. So our error handling would not have any effect here. Let's instead handle our error at the level of our store. We are going to then remove this local error handling operation, and later on we are going to see how to perform our error handling inside the store. And with this, we have defined and explained the strategy that we are going to adopt for data modification operations, which will be an optimistic save strategy. We have also defined the public API of the store, and we have shown how the operation is going to be consumed by our course dialog component. Let's now go ahead and implement step by step our save course method. Hello everyone, and welcome back. In this new lesson, we are going to show you how to implement an optimistic save operation in a behavior subject store. So we have here our courses store, which has in its public API a save course method that allows us to modify the data of a single course. You can see that this is returning here an observable of any. This observable is going to successfully complete if the save is successful, and it's going to error out in case that something goes wrong. Let's see how we're going to then implement our optimistic save course operation. Let's remember that our first objective is to modify the data immediately in memory and emit the new value of that same data here via the courses observable to any other part of the application that needs the data, such as, for example, the home component. So if we edit here a course using the course dialog and we click on save, we are going to expect the dialog to close immediately, that no loading indicator is shown to the user, and that the new data gets immediately reflected in our user interface without any extra delay. The save is still going to happen, but it's going to happen on the background in an optimistic way, assuming that it's going to go through on the server. This means that here in our save course method, we effectively want to do two separate things. We want to update the data in memory first, and then we want to trigger a save to our backend. Let's start with the first part, which is going to be to modify the data in memory. So where is our data, the list of courses? If we scroll up, we are going to see that here in our courses store, we have here as a private property a behavior subject. The behavior subject has the particularity of remembering the last value that was emitted. So whenever we emit here to our front end this list of courses, the behavior subject is going to keep in memory a reference to the course list in case that a new subscription comes along and the new subscriber needs to receive the last value emitted before the subscription. So this means that the subject here has a reference to the current list of courses somewhere. Let's grab that reference here at the beginning of our save course method. We are going to be defining here a new variable called courses. Let's now access our private subject and let's call here the getValue operation. This is going to return us the last value emitted by the subject, which is going to be a list of courses. So if I click here on the courses variable and I use the shortcut Ctrl+Shift+P, I'm going to see that indeed this is a course array, as expected. So this is the list of courses that was last emitted by our subject. Now what we want to do is inside this list of courses, we want to identify the course that we want to modify. We want to find what is the index of that course in our courses array. For that, we are going to be defining here a new constant called index, and we are going to go over the list of courses, and using the find index array operation, we are going to be finding the first course that contains our course identifier. Let's take here a course in the index, and we are going to be returning here true on this predicate function if the course identifier equals the course ID that we have received here as input. So once this predicate function evaluates to true, findIndex will know that we have found our first match, and we are going to get here on the index constant the position of the course in our courses array. Let's take a moment here to slightly reduce the size of the font so that we can see everything that is going on. So now that we have here the index of the course that we are modifying, what we want to do is to create a new version of our course containing all the course changes. Let's then define here a third constant that we're going to be calling new course. Now we are going to start by populating this new object with the current value of the course. We can grab the current value of the course by accessing the courses array and by accessing the course at the index position that we have identified here. So this is going to be an object containing the current version of our course without the changes applied yet. We are going to use here the object spread syntax in order to get here a new version of our course. Let's go ahead and also annotate this with the course interface so that we know what type the new course object is. So here at this moment we have a copy of the current version of the course. Let's now apply on top of that the changes that we want to apply to our course. So let's say that we want to change the title of the course. We would receive here a partial course object containing only the new version of the course title. So in order to apply all the changes to our new course object, we are going to again use the object spread notation, and we are going to apply here all our changes. So we now have at this point a new object containing a new version of our course, containing all the applied changes. This new course object still exists only in memory on the client side. This has not yet been sent to the server. Now what we want to do is to create a new version of our courses array. So not only one course, but a new courses array containing inside that array the new version of our course that we have just modified. So the first thing that we want to do is to create a new constant that we're going to be calling new courses. So this is going to be of type course array. We are going to create here then a copy of our current courses list. We can easily create a copy of an array using the array slice method. Slice allows us to extract, as the name indicates, a slice of the array and create with that a new array. If we pass in here the value 0, we are going to create a complete copy of the courses array. So it's a different array pointing still to the same objects. Now in this new courses array, we want to access the index position. So this is the position where the course that we are modifying is present, and we want to assign to this position our new course object. So in this new array, the only difference towards the original array is the course that we are modifying. The new array contains a new version of our course containing all the changes that we are applying here. Now what we want to do is to notify the reminder of our application that there is this new version of the courses array that can be immediately used by any components that are subscribed to the courses observable. So now at this point of our save course operation, what we want to do is to emit this new value, the new courses value, to the rest of the application, and we can do so again using the private subject next value. Let's then emit this value new courses. So at this point, the rest of the application will already have received the new courses, meaning that the user interface can immediately reflect the changes that we have made. Now, the changes that we have done to our course object are only present in memory on the client side. We now need to send these changes to the backend in order for them to be saved on the database. So in order to do that, we're going to be using here the Angular HTTP client, and we are going to be calling here the put function. So what endpoint do we want to hit? We want to hit the /API/courses, and then we need to pass in here the course ID. To this endpoint, we need to pass a JSON payload containing the changes that we want to apply to a given course. So now we have here an HTTP observable that is going to complete successfully when the changes on the backend are successful, and is going to error out in case that something goes wrong with our backend call. So we can now already go ahead and return this as the output of our save course method. As usual, we are going to be taking here a couple of precautions. We are going to apply here the pipe syntax, and we are going to apply here the share replay operator. This is so that multiple subscriptions to the returned observable don't accidentally trigger multiple HTTP put calls. We also want to add here some error handling. So we are going to do that before share replay so that the error handling only gets triggered once, and the error handling is going to be very similar to what we have done before. So I have just pasted it in, as it's very similar logic to what we have reviewed earlier on in our course. We are using here catch error. We are catching the technical error that occurred. In this case, this would be a backend error. And we are defining here a new message, could not save course. We are going to log this to the console together with the technical error. To the user, we are not going to be showing the technical error directly. Instead, we are going to be showing only the user-friendly message could not save course. And we are returning here the same error as usual using throw error. And with this, we have finished the implementation of our save course method. Let's summarize what we're doing here. We have created here a new version of our course object containing all our changes, and we have emitted that new value to the rest of the application immediately using subject.next. The application is going to reflect the new data immediately, and on the background we have also called here an HTTP put operation in order to save the data on our backend. However, we are not showing here any loading indicator while the save is ongoing. We are now almost ready to try out our save course operation, but before doing that, we're going to go here to our component, and we are going to remove here the logic that was reloading our courses list whenever a data modification occurred. So we no longer need this logic here. Our user interface is going to optimistically reflect all the data changes immediately. Also, before trying things out, we need to fix here a small bug in our implementation of save course. So the index that we want to update here is from the new courses array. So we need to use here new courses and not, like I was doing here accidentally, new course. So new courses is our array, and it's on this new copy of the courses array that we want to save the new data and emit it to the rest of the application. And with this fix in place, we are now ready to try out our new optimistic save course operation. We have reloaded here our front end, and we can see here the initial request to load the courses from our backend. So our course list is here. Let's now see our optimistic save operation in action. I'm going to open here the dialog. I'm going to edit here the title of the course, and let's say that we are going to switch the category from beginner to advanced. I'm going to click here on save, and notice that the dialog is going to close immediately and that no loading indicator is going to be shown to the user. Also keep an eye here on the network log. We're going to click on save. Our user interface has immediately reflected the changes while the save was still ongoing in the background. We can see that the save has completed after a couple of seconds, but the data had already been reflected on the user interface, so the course was moved automatically from the beginners tab into the advanced tab, and we can see here the new version of the title. Let's edit this again. I'm going to edit the title and remove this last part, and let's switch it again back to beginner. Let's keep an eye here on the network log. The user interface gets immediately reflected while the save was still ongoing in our background. So this is how we implement an optimistic save operation in a behavior subject store. Let's now continue our course. We are going to start now a new section on user authentication. We are going to learn how can we use a behavior subject store in order to help us implement some very common user authentication use cases.